Hey everybody. This is a short but very thorough introduction to data visualization in R using the modern ggplot2 package. That's included in the tidyverse family of packages, and my first line of code here, library tidyverse, is loading up all of that. I'm also going to load in model data. That includes the crickets dataset that I'm going to be working with throughout this vid. The crickets dataset includes 31 observations, including temperature and rate. How sort of warm was the room, and how fast did the crickets chirp. We also have two different species of crickets, and that's encoded in the species column. I'm going to start with a scatter plot of rate and temperature. The first thing to know about graphing in R with ggplot is that with this philosophy, the grammar of graphics philosophy, the most fundamental and important thing about a plot isn't so much whether it's a histogram or a scatter plot, but rather which variables are being used in the plot and how they're being displayed. Are they on the x-axis, the y-axis? Are they using color, size, or something else? We specify these things first, and then only specify the exact kind of plot, scatter plot, histogram, etc., later. I think it's easier to see than to hear. So let's get our first ggplot call. We only have one function for plotting most plots in R, and that's ggplot. The first argument is just the data set, crickets. If you're trying to do a plot that's not using a data set, either you're not really wanting to work in R specifically is for working with data, or you need to do a little pre-processing first to get the data in the right format, to get it in a data frame format. This goes along with the tidyverse idea that we should separate out our data preparation from our data visualization. Okay, the next thing we need to specify in our ggplot call is which variables are being displayed where. So if I want a scatter plot of rate versus temperature, I want the rate on the y-axis and the temperature on the x-axis. So I specify within the aesthetic, AES, I say x equals temp and y equals rate. So how are those variables being mapped to the actual visualization? How are they going to be displayed? Okay, now that I've specified what variables I want, where, it's time to actually tell R how to display the data. In other words, to tell R that I want a scatter plot. And I do that by specifying geom point. In general, we specify the sort of plot we want with plus geom underscore and then the type of plot. So we'll later see geom histogram, geom bar, and a few others. Here, geom point. So for a basic scatter plot, that's all I need. And if I hit Command Enter, we can see that here in the lower right. I'll zoom in on it to make it a little bit more clear. There we go. Notice that temp is the exact name of the variable, the exact name of the column that we are plotting. Rate, same thing. So the labels have been put in automatically using column names. And then for each row in the data set now, we have a single point on the plot. Great. So there are any number of things we can do to improve or change the appearance of this plot. And the philosophy of the grammar of graphics, and ggplot2 in particular, is that those sort of non-data aspects of the plot should be handled separately after we've got the basics of it down, after we've specified the data set, the variables, and the geometry, the geom. For instance, to change the labels, we do plus labs. Self-explanatory, the name of that one. And then we have to say what we want the label on the x-axis to be. So in this case, how about I capitalize it and put temperature? And on the y-axis, I'll put rate. Maybe I'll put chirp rate. There we go. We can add a title. Let's do that. How about crickets? Cricket chirps. We could add a subtitle if we wanted. I don't think I'll do that. We can add a caption. Captions are often nice to cite your sources. So in my help file, crickets, I can see a citation for McDonald 2009. For the moment, I'll just put McDonald 2009. If this were an actual plot for publication, I'd probably be a bit more descriptive than that. Okay, so now you can see the title of the plot and the source. I think I actually want to label that is the source. There we go. So that looks a little better. Okay, so there's lots of other aesthetics we can use. In this case, we said we wanted to plot temp and rate on the x-axis and y-axis, respectively. What about if we want to color this by species? So what I'm saying is that the species variable should be displayed in this plot. I want to map the species variable onto this plot onto a color aesthetic. So I'm just going to add color equals species inside of my ggplot. And if I zoom in, you can see that now I have two different colors here. I have a legend on the right that went in automatically. I'm not in love with the fact that everything else has a capitalized letter at the beginning. Here, I do not. I want to change that label as well. The labs command here can be used to change the labels on the color aesthetic in exactly the same way that it's used to change the labels on the X and Y aesthetics. I just do color equals quote capital species. And there we go. You can see that now species in my legend here is capitalized. One potential problem with this comes in if you are colorblind. You may not be able to tell the difference between these two colors here. The default color palette in R and ggplot isn't great in that way. For improved accessibility, I recommend this line of code that I won't say too much about. It's scale, color, brewer, palette equals quote dark 2. And that'll change it to a slightly higher contrast, more colorblind friendly palette. Scale, because I'm changing the scale on a certain aesthetic. Color, the name of the aesthetic. And then brewer is referring to the package from which this color palette is taken. So adding that on at the end of my line, plus scale color brewer, changes my color palette to something a little bit more friendly. All right, wonderful. Let's see here. Let's go put in some comments here. So I'll comment this one as the basics. Doing a scatter plot, changing the labels, adding some color to it. Good basic stuff. Let's make some more modifications. I'm going to go back to this first one. I don't want to color it by species just for this next few, these next few examples. How about modifications? How about modifying basic properties of the plot? So we know now how to change or decide which variables are being represented in the plot and how those variables are being represented. But what if I just want to directly make a change? What if I want to take these points and just make them all red? I don't want them to come from a variable now. I just want to specify red. That's not an aesthetic. That doesn't go in here. Aesthetics tell us variables and how they're being displayed. If I want just a basic property of the geom, well, that goes inside of the geom. So for instance, to change the points to be a red color, it would be color equals quote red. You can specify colors using hexadecimal codes. There's other ways to do that as well. There's something like 600 or 700 colors that are recognized just by name. So there's some interesting ones. There's like peach puff is one of them. That one's not a high contrast one at all. You can do gray. There's like 8 different grays or something. I think red was the most visible, so I'll stick with that. We can change the size of the points. For instance, we can make them larger. Size equals 2. Sometimes you just tinker around with that. There's size 5, for instance. So making them 5 times as large. I think I'll leave it 2 for now. Another thing I want to make you aware of is that you can change the transparency. If you add alpha equals, and then you put in a number between 0 and 1, it'll tell you sort of how opaque it is. So I can make them 80% opaque with alpha equals 0.8. Maybe I'll make it alpha equals 0.3 so that it's even more apparent from my plot. This is particularly helpful if you have potentially over-plotting. Okay, size, alpha. One other thing you might want to do is shape. For instance, we could change our shape so that all the points are represented as squares, and you can see that pretty clearly here. Instead of the dots, I have squares. Learn more about the options for the geom. Oops, I need this to be a comment, sorry. Just by question mark geom whatever. One of the really nice things about this structure for ggplot is there's not just a help file for ggplot. There's a help file for every single one of your geoms, like geom point. You can get the help file for labs. You can get the help file for scale color brewer, for instance. All of these things have their own help files, and that allows for a much higher degree of granularity in the kind of help that you can get. Okay, let's see here. Adding another layer. Okay, so I'm going back to this first one again. I'd like to put a regression line over this. This is a more or less linear shape. There's certainly, it's not a perfectly linear relationship, but it's relatively close. That's just another layer on the plot. I still want to be using the x values of temperatures and the y values of trip rates as I calculate the regression line. One of the great things about ggplot, you can just add as many layers as you like. It's like you're working on a canvas, painting one layer, then another, then another. So after my geom point, I will put geom smooth. And for the moment, I'm just going to leave it as is. It won't be a regression line yet, but that's okay. Okay, so it's almost like a line, but if you look, if you look closely, you'll see it's kind of a little bit squiggly. This is R's default way of fitting a smoother or a curve of best fit over the data. It's using a low S curve that's kind of a rolling polynomial fit, not a regression line. So that can fit the data a little bit more closely and be a little bit more flexible as it captures the trend of the data. It's a little bit more opaque. There's not a simple formula for this. It doesn't contribute as much maybe to our understanding of the relationship between these two variables as a regression line would. So I want to go in and make this an actual line. Just like I could add arguments to geom point to change the qualities of the points, I can add arguments to geom smooth to change the qualities of the smoother. In this case, I want method equals quote lm. Use a linear model. And of course, I could learn more about how to do this with question mark geom smooth, and the help file would give me lots of good guidance on that. Now you can see it's actually a regression line. Notice the gray bar here, that error ribbon. That's giving us some measures of uncertainty in this regression line if we're viewing this cricket data as sample data from a larger population. That can be helpful in some circumstances. In others, it can just make the plot seem more noisy or busy. I'm going to remove it just to show how with SE equals false. So SE for standard error, take out the standard error ribbon. Notice that there's a comma separating the arguments. Notice it's inside of geom smooth, just like so. Fabulous. So we've got a decent regression line for this data. Last thing I want to do on this scatter plot is point out what happens if I do a regression line when I had added a color aesthetic. So looking at this plot, remember here I have each species with a different color. And you can see that within each group, we've got a pretty good linear relationship. In fact, the nonlinearity in the original plot is probably due to the fact that really there's two species here, each of which have a very linear relationship. Let's go to geom point and after that add a layer that is geom smooth. And I will stick with method equals quote lm so that it's a regression line, and SE equals false so that it is taking out the standard error ribbon to make the plot a little bit less busy. Fabulous. So now you can see that the linear model that we've created here is a very good fit for the data. There's, if we were to do residual plots on this, for instance, we would see that all the diagnostics come up looking very, very good. Wonderful. Let's see here. How about other plots? I did with scatter plot. It's just sort of like an illustration, but there's nothing special about a scatter plot at all. It's a 2 quantitative variable plot with which you can add a color aesthetic as well. What if you just have a single quantitative variable or a single categorical variable or one of each? These are all different sorts of plots with corresponding different geomes. So let's do a few of these. Let's get a histogram of the chirp rates. So ggplot crickets, first I name the data set. AES, I name the variables that I want and where I want them. So in this case, I want chirp rate. In this case, that's all I want. A histogram represents a single quantitative variable with frequencies going on the vertical axis typically. Frequencies being computed just as counts in the data. So really there's only one column being considered here. And then to get a histogram, I want to add geome histogram, naturally enough. So there you go, you can see it. The default, as we got in the message here, is to use 30 bins, which isn't a particularly fabulous number. It's intended, I think, to be kind of a default that will get you to tinker around. I think good data exploration practice is to try a bunch of different numbers of bins. Sometimes the trends you see in a data set will be very different if you're looking at a lot of bins versus a very small number. Just for illustration, I will change the bins to 15 here. There we go. You can also change how the bins are displayed with bin width. So instead of bins equal 15, I could put bin width equals 5, for instance. All right, lovely. That is for one quantitative variable. I think this is a good moment to see the strength of the ggplot perspective, the grammar of graphics perspective, that histogram should come later in the call, not right up front. Let me just change from histogram to freq poly, freqpoly. This is going to give me a frequency polygon, and I want you to watch and see how the plot changes, but then also how it doesn't. And I'll just do the other one again. Can you see how this is exactly the same plot, just represented in a different way? The fundamental feature of this plot is not that it's a frequency polygon, or that this one is a histogram. The fundamental feature of the plot is that chirp rate is on the x-axis. So it makes sense to specify the chirp rate from the cricket's data set first, and only come back later and specify a frequency polygon. There are a lot of other single variable geomes that are available to you. I'll talk a tiny bit more about that in just a minute. Let's do a plot for the species variable. It's a single categorical variable. I want a bar chart. So ggplot crickets, if I can type properly, which is always my challenge. And this time I want my X aesthetic to be species. And I want geome bar. There we go. I'll zoom in on that a little bit. You know, we can do all of our usual things with this. We can change the labels on this. We can put a title. We can add some color. Let's actually do that. Let's add, how about color equals, I'll start with black. Could you see that difference? So color gave me the boundary color. If I want to actually do the inside, I need fill. And so it's fill equals, I don't know, so we've got black on the outside. How about light blue on the inside? Let's give that a try. It's all right. I'm not sure I love the color choices. I'm not a graphic designer, so it's not always perfect in that way. Notice that those colors are not being specified by a variable. The colors are being specified just manually. I'm saying make all the bars light blue with a boundary color of black. Now, we can have the color specified by a variable. So I'm just retyping x equals species. Let's make the fill equal to, well, species. Try and imagine what that's going to do. So this time we have one aesthetic, species, but it's showing up two different ways. species is being communicated on the x-axis as well as with the color aesthetic. So, actually, before I do anything else, let me make this a bit more accessible with Scale Color Brewer. And actually, wait, it should be Scale Fill Brewer this time because it's a fill aesthetic. And I want palette equals, quote, dark 2. Accessibility or bust. Okay, so the color is nice. It looks a little bit more professional. We have these two different groups with two different colors. The downside is we have the label happening twice. We have the x-axis as well as the legend. We don't want this legend, honestly. We'd be just as well off without it, probably better. So that's a special property for GeoMBar, and we can adjust it with show.legend equals false. So don't show the legend. There we go. So now the species variable is being communicated in two different ways, but we only need one label for that. We don't need that extra legend. Okay, great. So the bar chart is your default go-to for a single categorical variable. Your histogram is generally your go-to default way of displaying a single quantitative variable. The scatter plot is good for two quantitative variables. The last one I want to show right now is for one quantitative and one categorical variable. And a good way to deal with that is with a box plot. So I'll stick with crickets. On my x aesthetic, I'm going to put species. On my y-axis, for my y aesthetic, I want rate again. And I want a geom box plot. And I'll zoom in on that. Again, the categorical variable species is going left and right. The quantitative variable rate is going up and down, just as I said in my aesthetics here. And then it's generated a side-by-side box plot showing the chirp rates for each of these two different groups. Remember, a box plot is a visual representation of your 5-number summary. So you've got the minimum, first quartile, median, third quartile, and maximum for each of these two sets. You can do things like messing with the color and the fill here. So for instance, we could do, I don't know, how about color equals species? So this time each of the two will have a different color depending on which species of cricket they are. And I guess I should do my usual stuff. I'll just copy and paste to make that accessible. And I'll also copy and paste the show legend equals false so that that's not repeated. Okay, great. When you're planning out a data visualization, you should be thinking in terms of which variables you're using, whether they're quantitative or qualitative. And this corresponds very directly to the data question you're asking. In this case, I'm interested in a data question relating chirp rates to the different species. Something like, do these two different species have different chirp rates? Or do the exclamationes, sorry for the pronunciation, do they have a higher chirp rate on average than the Niveus? And so this visualization helps answer that question. Once you've decided that you have a single quantitative and a single categorical variable, that gives you guidance into what sort of geom you might want to be using. I have a little flow chart that I'll show you, and I'll put this up on my GitHub in case you want to download it. When I'm planning a data visualization, I'm starting by asking myself how many variables I fundamentally have. Do I have 1, 2, I'll talk about 3 in a second. If I have a single variable, I ask myself, is it categorical or quantitative? If it's categorical, my go-to is a bar chart. If it's quantitative, my go-to is a histogram. Obviously, there's other choices, but these are your most basic and generally the clearest ones that you could pick. If you have 2 variables, you can have 2 quantitative, a scatter plot. You can have 1 of each, like the box plot that I just showed you. And if you have 2 categorical variables, you probably want a grouped bar chart. I'm not going to talk about those in this video. That gets a little bit more complicated. I do have a whole video on that, though. I'll throw a link to that up top if you want to delve into that, please do. More broadly speaking, if you're looking to do more specialized, more interesting, more potentially advanced data visualizations, and you're curious about how to expand on this flowchart, I'd recommend the ggplot2 cheat sheet that Posit has published. It looks like this. You can find it with a quick Google search. In particular, for instance, if you have one discrete and one continuous variable, here are some other options that you might explore. For instance, a violin plot or a certain kind of dot plot here. This is really helpful. You also have a lot of information here about how you can modify things like scales on your visualization. By the way, you don't actually need to Google it. You can go to the Help menu, and you'll see in RStudio the Help menu has a cheat sheets option. So you can go there and you can find where's the data viz one? There it is. As well as cheat sheets for many other things like data wrangling with dplyr. Great. Okay. One other thing I want to do before I'm totally done with this last box plot, and that is with this particular plot, because they're white with the colored boundaries. Hey, I thought I changed the color palette. It should be scale color brewer. There we go. Okay. Did I have the same issue up here? No, that one's okay. All right. So what I wanted to say is with this these white boxes, I don't love the gray background. I'm never fully in love with that gray background that ggplot puts in by default. But here in particular, we can take that out. And in fact, I kind of recommend taking it out by adding theme minimal. There we go. By the way, there's other themes available to you. And if you do $theme minimal, it'll give you some other options for complete themes. So, you can explore that on your own time. By the way, it is possible to change things sort of manually and go in and say, all right, I want to myself specify that I want the background to be yellow and I want these bars to be orange or whatever. In general, I recommend against that unless you're a pretty advanced user, and in particular if you're pretty advanced in your understanding of graphic design, which I'm certainly not. Usually when beginners with data visualization tinker with that kind of thing, it comes out looking worse than in the predefined themes. Generally, I'd say pick a color palette, use something like theme minimal, there's a few other good ones, and then just let it go from there. And if you need to do more finely grained things, find a partner that really knows what they're doing in terms of graphic design. The last thing I want to do here is faceting. So sometimes introducing, before I do that, I'm sorry. In my planning a data visualization thing, I have 2 variables here. I didn't talk about 3 or more. So I want to say something about that really quickly. In general, I only recommend adding a 3rd variable to a data visualization if you can do so pretty clearly using a color aesthetic or something equivalent to a color aesthetic. For instance, shape. A lot of times when you start putting in 3 or 4 aesthetics, mapping 3 or 4 variables to the same plot, the point of the plot becomes lost. Remember, a plot should be communicating a clear data point. Frequently, one data point, not many. And when you put in 3, 4, 5 aesthetics, you start detracting from that, and the plot becomes harder to read. So if you've got a scatter plot with 2 quantitative variables and you want to add a color to it, yeah, that's great. Same thing with those, with some of these others that we might have talked about. I don't generally recommend representing a 4th variable. I generally don't recommend trying to represent, for instance, 3 quantitative variables on the same plot. ggplot2 doesn't support 3-dimensional graphs. Those sorts of plots are often not considered best data visualization practice because fundamentally it's a flat image representing 3 variables, which is relying on optical illusion that can get deceptive or misleading very easily. So I would discourage you from doing a 3-dimensional plot unless you just want something pretty that's not really supposed to be fully telling a data story. There's exceptions to that, like every rule, but that's my general thing. Okay, now for real faceting. So I think the point of faceting is clearest if we try and do, say, chirp rate broken down by species in a histogram. So let me show you that. I want to do ggplot crickets, no I at the beginning of crickets. On the x-axis, I want to put rate, and I want to fill according to species. So basically, I want to add this categorical variable in to my histogram, my geom histogram. And this is a valid plot, but I think, at least for me, it's not attractive and it's not going to be overly helpful. While I'm at it, I'm going to put in a scale fill brewer, palette equals dark 2, just out of habit. And let's do 15 bins like we did before. Okay, so it did what we asked. It gave us this histogram with rate on the x-axis, colored by species. But it's not the easiest thing to interpret. It's sort of stacked the exclamationesses on top of the Neveuses. And here you can kind of tell that the exclamationesses have higher chirp rates, but it's not the most clear plot ever. And if you have 3, 4, 5 categories, this can get really, really ugly. Honestly, the better way to describe this data and these two variables is with side-by-side, or plots that are right on top of each other. Separate plots for exclamationists and for Nevus. Now, the more complicated way to do this would be to break the data set down into 2 separate data sets and make 2 separate plots. It's a lot of work, it's repetitive, and there's some technical problems with that as well. For instance, there's no guarantee that the scales in the 2 plots will be the same, and so you might not necessarily want to put them side by side, even if you had them. The best way forward here, and for the moment I will just take out the species aesthetic, the fill species aesthetic. Let me just make a note for my for the saved file that that's not great. So the first thing I'm going to do is take out that aesthetic. So I want still to do a histogram of rate. And I will stick with 15 bins. And this time, I want to do a facet wrap. And this is saying, just give me a plot for every different value of the categorical variable I'm going to specify next. And the variable I want is species. Notice this syntax, tilde species. So basically wrap it by species. And I seem to have made a mistake here. Let's see here, what is it? Where's my plot? Where's my function? Where's my mess up? It doesn't like my facet wrap. Facet underscore wrap by species. Oh, it's ggplot is my problem. I just literally misspelled ggplot. And now it says I have an extra parenthesis here. There we go. Okay, finally we have it where we would like it. Okay, so now we have side-by-side plots for these 2 different species of crickets. Notice that the scale for counts is the same on both, even though the counts for the bins for the exclamationesses only go up to 3. If we had made the plots separately, the scale would have been different. Here they're the same, and that makes it easier to compare the 2 side by side. Similarly for rate, they both go from about 40 to maybe 110 or something. All right. Let's add in some color. Let's do it the same way as before. Let's add in a fill aesthetic. Let's fill it by species. And if I'm going to do that, I should copy and paste my colorblind friendly palette, like so. So now we've got some color in there. We can take out the legend. So show.legend equals false. All right. Lovely. There's all sorts of other modifications we could do. We could change the labels. We could get rid of that gray panel background with the minimal. The one thing that I really would like to do here is to arrange these plots vertically. The difference here between these two plots is really that the Nevaeuses have a lower chirp rate. In other words, the bars for the Nevaeus crickets are further to the left on average than for the exclamationists. But because these are side by side, that difference isn't fully clear. You can get lots of help, of course, with facet wrap with facet_wrap. And that pulls up a help file that includes both facet wrap, what we're using, and facet grid, where you would wrap it according to two different categorical variables. The argument that I'm wanting to add here is either n row or n col. How many different rows or columns of plots do I want? And in this case, I'll just copy and paste, I just want one column. So I'll put n col equals 1, and that should do it. And I'll just put the plots right there. Okay, now I think this is a relatively clear plot where we can see pretty directly that the Nevaeus crickets have a lower chirp rate on average than the exclamationist crickets.